All right, so for part 2, we're going to be solving systems of nonlinear equations. For number 9, it says we're going to solve the nonlinear system and then we're going to verify it with our graphing utility. Okay, so first, looking at it, I have x squared and a y and an x and a y. So because those two are, you have an x squared and an x, you're going to have no choice but to use substitution to solve this. So to use substitution, well, I'm going to have to get it into x equals or into y equals. I'm going to tell you now the easiest thing to do. I don't want to have to square anything at all, so I'm going to turn it into y equals so that I can then just plug it in. So what I'm going to do is I'm going to solve. I'm going to take this bottom one first. And he's the one that I'm going to rearrange so that he's in a y equals format. So to get at y equals, I'm going to move the 3x over. So I get a negative y equals 9 minus 3x. And then, of course, I don't want a negative y. I'm going to have to move that negative by changing everything. Every single sign of everything in your problem is going to have to change, or it's like dividing by a negative 1. But we end up with y equals negative 9 plus 3x, or if you're rewriting it, it would be 3x minus 9. I like my x's in the front, so I'm going to rewrite mine, 3x minus 9. All right, so this is the one that we're going to use, and we're going to plug it into our first equation. So we're going to have x squared equals 2. Remember, replace that y with our 3x minus 9 that we got, and then our plus 10 at the end. You have to remember that if there's a constant at the end, he has to be in there too. So I get x squared is equal to, I distribute the 2 to get 6x minus 18 plus 10. We're going to get x squared equals 6x, combine like terms to get a negative 8. But of course, I'm not looking for, in order to solve this, because it's an x squared, I'm going to have to move everything to the other side. So I get x squared minus 6x plus 8, and that's equal to 0. And to solve it, I'm going to have to factor. So I'm going to go what times what gives me 8, but adds to be a negative 6. Well, that's going to be an x minus 4 and an x minus 2. So I get x is 4 and x is 2. So I'm going to take those two numbers that I got, and I'm going to use that y equals 3x. I use that one because, well, it's easiest to plug something in. No matter what I plug in, I'm going to get a y. So I get y equals 3x minus 9. Okay, I'm going to plug in my 4 first. So y equals 3 times 4. Minus 9. 3 times 4 is 12. 12 minus 9, well, that's 3. So y equals 3 for that one. Now I'm going to plug in my 2. Y equals 3 times 2 minus 9. So y equals 3 times 2 is 6. 6 minus 9 is negative 3. So when I go to write my answers, I have to remember I plugged in a 4 and I got a 3. And then I plugged in a 2 and I got a negative 3. So these are my two solutions to my problem. All right, now looking at my next one, it's very similar to the previous one. So I know I'm going to have to, again, put it into y equals. So I'm actually going to do it where I put the top equation into y equals. So I know I'm going to move that 1 to the other side. So I'm just going to go ahead and do that. So plus 1, and it'll be plus 1. So that I get y equals x squared plus 1. So I'm going to take that y equals, and I'm going to plug it into my my second problem. So I get 4x minus, instead of y, I put my x squared plus 1, and it equals a negative 1. Remember, you have to distribute the negative that is outside of the parentheses so that you get 4x minus x squared. That becomes a minus 1, and it equals minus 1. Move that 1 to the other side. So plus 1, because we want everything on one side. It's always going to be on the side of the x squared, so that we get 4x minus x squared. And that positive 1 and negative 1 cancel each other out, so it's equal to 0. I know I'm going to they have an x in common, so I'm going to pull an x out. So I get an x out, I get 4 minus x, and it equals 0. Well, if I set them both equal to 0, I get x equals 0. Set him equal to 0. I move my 4, so I get a negative x equals negative 4. Well, that becomes x equals positive 4. So I get x equals 0 and x equals 4. I'm going to take those and plug them in to my first equation. So y equals, and instead of x squared, I'm going to put 0 squared plus 1, which gives me 1. And then I get y equals 4 squared plus 1. 4 squared is 16. 16 plus 1 is 17. When I go to write my answer, again, I plugged in a 0 and I got a 1. Plugged in a 4, got a 17. Those are my two solutions. Now, looking at this last one, I'm actually going to treat it differently. I have x squared, y squared, y squared. I have the ability to actually use elimination in this one because all I have to do is change the y squared so that one of them is opposite sign, and then I can just add them together. So I'm going to change everything in the bottom to a negative. So I'm going to multiply everything on the bottom by a negative 1. So I get 4x squared plus y squared equals 13. All my signs change for this one, so minus x squared minus y squared equals negative 10. All right, 4x squared minus x squared is a 3x squared. My y's cancel each other out, and 13 minus 10 is 3. Divide by 3. I get x squared equals 1. Well, of course, in order to solve the x squared, I'm going to have to take the square root. Well, square root of 1 is just 1, except because it's the square root, it's a plus or minus 1. So I have a plus or minus 1. Now I'm going to have to take it and plug it in. So I'm going to pick a problem, any problem. I'm actually going to choose the bottom one. And I'm going to plug in first a positive 1. So I'm going to take my x squared plus y squared equals 10. That's the one I'm going to use. And I'm going to first plug in a positive 1. So I get 1 squared plus y squared equals 10. Well, that's 1 squared is 1. I'm going to have to move it to the other side. So I get y squared equals 10 minus 1 is 9. To solve, I take the square root. And of course, anytime I take the square root, I get a plus or minus 3. So I plugged in a positive 1 and got a positive 3. I also plugged in a positive 1 and got a negative 3. Now I need to do it one more time because I need to do it for the negative. So I do the same thing. I'm going to use my x squared plus y squared equals 10. But this time I'm plugging in negative 1. Well, you know what's nice? Anytime I do this, all right, negative 1 squared is positive 1. And in order to move that positive 1, I'm going to subtract 1 to the other side. So I still get y squared equals 9. So I know, again, I plug in a negative 1. Oops, sorry, guys. And I got a positive 3. And a negative 1 gave me a negative 3 because when I took the square root, I got plus or minus 3. So I ended up with 4 solutions. So here's those two and those two. But they are all part of my answers. Now, to use your graphing utility to do this, obviously you're going to make each one of these into a y equals. So in order to do that, I'm going to come over to the side. And I would have to take this x squared equals 2y plus 10. And I would have to move everything to the side of the x. So I get x squared minus 10 equals 2y. Of course, I divide everything by 2. So in my calculator, I would put y equals, you could either do it like 1/2 x squared or minus 5, or you could do it all with x squared minus 10 over 2. Doesn't matter, as long as you use proper parentheses. Obviously, we already solved one for y equals, so we're going to, in y2, you would put y equals 3x minus 9. Now, in order to do that, so I actually went to Desmos.com, my favorite little website here, and I plugged them in. I have a 0.5x squared minus 5 and 3x minus 9. Now, in Desmos, I can take it, and I see that I can, again, pinpoint it at 2, -3, and at 4, 3, which are my solutions. Oops, sorry, guys. Right? I got 4, 3, and 2, -3. So again, you would do the same thing for B and again for C, but I'm not going to go through them for that one. All right, 10. We're going to graph y is greater than x squared plus 1. Now, if I remember correctly, remember I'm going to have a dashed line because that's a greater than, and then x squared plus 1. I'm going to graph it like I would anything else. That plus 1 tells me that's where it starts. And I'm going to choose a number to the left and a number to the right so that I can then draw my line. But remember, it's an x squared, so what's really going to happen is you're actually going to have a U shape. Now, if you want to be specific, you could plug in 1 squared plus 1. So I would end up with 2, so 1, 2, which of course I would mimic on the other side with a -1, 2. And then I could do it again for 2. So I would get 2 squared is 4, 4 plus 1 is 5, so I would get 2, 5. And of course I would get 2, oops, that's not a 5. 2, 2, 3, 4, 5. And I would mimic it on the other side at -2, 5. Then I would draw a dashed line because it's a dashed line. Now remember, everything, it says y is greater than x squared. Well, greater than means everything that is above the line, and everything that above the line occurs inside of it. All right, for 11. This one wants us to graph y less than x plus 3. Well, we can do that nice and easy. So I start at 3, 1, 2, 3. And of course, I'm going up 1 over 1 and down 1 over 1, right? Because m is 1 and the y-intercept is 3. And then I am going to take, and again, I'm going to have a dashed line going through it. Remember, go all the way through your graph and draw your arrows at the end. Now it says y less than 3, so everything underneath the line. Now, of course, we're going to combine them for our next problem 12. So again, I'm going to draw them in different colors this time. I have y greater than x squared plus 1. And I'm going to do y less than x plus 3. So again, I'm going to start at 1. Oops, wrong color. Start at 1. I know I had 1 at 1, 2, and at 2, 5. So I mimic it on the other side. And I'm going to draw my dashes. Draw my dashes. Okay, next one starts at 3, 1, 2, 3. And of course, I went up 1 over 1. They intersect in 2 spots right there. Of course, draw my dashed line. And just like previously, whenever we were doing this, we're trying to figure out where they overlap. So again, I had everything was greater than up here. So this will be all red. And of course, it was everything less than x plus 3. So if I draw my green, it's underneath the line. But if I look closely, I only want where they intersect. Well, they only intersect in one little piece, one tiny little piece. Oops, sorry guys, I didn't mean to erase all of that. They're going to intersect in this little piece down here, right here. So remember, darken it in, and that's your solution. Now we have some questions to answer. It says, do the two graphs intersect? Well, yes, they do. They intersect at 2 parts. And if we really needed to, we could say that it intersects at -1, 2. Right here is at this, and then at this, and then at this, and then at this one, it intersects at 2, 5. Okay, so I could put those as my solution, but I did not ask it. It says, what does the intersection mean? Well, it just means that the dashed lines, everything between the dashed lines is a solution, but nothing at the dashed line is a solution. So what does the intersection mean? Well, it intersects in 2 points. And everything between the dashed lines is a solution. Okay, now it says, is 0, -2 lie in the intersection? Well, let's take a look. We're going to try to plot it. 0, -2. So down here. Is that part of my shaded area? Well, no, it's not. So guess what? No, 0, 2, or 0, -2, sorry, is not a solution. Now it asks, is -5, -9 in the intersection? Well, again, I'm going to take it and I'm going to try to plot it. -5, 1, 2, 3, 4, 5, and I'm somewhere down here. I don't know. Well, that of course also does not occur in my solution. Now, if it would have asked, is 2, 5 a solution? Well, because it lands on my dotted line, well, then I would have to say no, because anything that lands on the dashed line is not a solution. So, this one's not a solution. But remember, if I would have asked if it was 2, 5, or if it was -1, 2, technically those are also not a solution because they are on the dashed line and not included. Okay. If you have any questions, please feel free to reach out to me. You have the ability to send me an email or message me on Remind. Have a great weekend.